Hey guys, no, I haven't shrunk. The TVs have gotten bigger. I think this is the largest black and white set I've shown on this channel so far. This is a 19-inch circular picture tube. It's a metal cone 19AP4. I've only worked on one set with this particular picture tube before, and I think that was before I started making YouTube videos. A long time ago. It's a Motorola set. This is a Capehart, and I've been tasked with restoring it. Also has a companion AM/FM radio. We'll get to that later. First, I want to check out the TV. I've already tested the picture tube. I know it's good because that's would be difficult to replace. So it's a little daunting to work on one of these because it's not just big, it's a metal cone. And this entire metal cone is attached to high voltage, around 16,000 volts or so. It's a thin plastic shroud around it that offers minimal protection. Also, while you're flipping this on its side and recapping it and all that, this is it's too big. Well, if you put this on its side, the edge of this will hit the workbench, so it's going to have to come out while I'm working on it, and I'll use my little 5AXP4 5-inch test CRT. It'll look comically small in this chassis. Now, the chassis I've worked on similar. Capehart was out of Indiana, and they were bought out by Farnsworth at some point. I don't know exactly what the history is. I think Farnsworth bought them initially because they needed manufacturing capabilities, but then they got out of the game, and for a while they sold sets with both names on them. Regardless, they used this chassis in a whole lot of sets, and they tinkered with it a whole lot. I think it's part of the 325 chassis family. I recall when I've worked on a couple of these before, even when you think you have the right service info, you find a lot of production changes. Plus, this was made around 1950, 51, when all the manufacturers were scrambling because of massive demand and part shortages, and you find a lot of oddities. So, let's take a closer look. It's a little hard to get the whole thing in frame. Now, why did I particularly want to unmount this CRT? But I really think I have no choice. Even if I could prop this thing on its side, there's too much of a chance of it getting damaged, let alone myself getting shocked when I power this set up. I think we see something here. Was it C297, something like that? Might be the chassis number. This is fine-tuning. The dial string is okay. So typical of Capeharts of this era, they have 4 knobs, and then there would be a logo panel that goes over these, and these would be fine adjustments. Let's swing this around. I guess I'll go this way. I think you get a much better sense of what we're dealing with here. So yeah, it's, it's one big ass picture tube, a big old power transformer. Design is fairly conventional. Turret tuner, 5U4 rectifier, power transformer. It's going to have the usual like 6 SN7s for the oscillators, and 6 AU6s and that kind of thing, and the IF and the tuner like you've seen me do in so many other sets. Really, the most unique thing about this is this. So there's that thin plastic sheet. From here to here, this is spun metal. And thank you for those who tipped me off about what that means. And actually, I had seen videos on the technique before. I just didn't put the two together. Put a disc of metal on a lathe, and you get a big old metal bar and a pivot point, and you press against it, and you form the metal, and it gets these distinctive marks from it spinning around while you run a metal pole against it. They form pots and pans and vases and stuff like that. Do the same technique. So they use this chassis or similar chassis in a whole bunch of sets with 10-inch, 12-inch, 16-inch, and then 19 would be the largest. So depending on what version you have, they cobbled together different things to get this height right and to get the depth right. So we'll want to make sure we put this all. That's why I don't want to take it apart, because I got to make sure I get everything back together right. So there's a metal ring around this plastic collar here. That's the main thing holding this down. I got a nut here. It's one on the other side. If I loosen those up, I can take this off. And got a dinky little ion trap magnet on it, single pole. Take this off. Base is on there firmly. And then if we're lucky, it'll just come right out the front. I gotta find somewhere very safe to put it. I'll put it over on the side table where I had the chassis resting. I don't know if the owner ever tried powering this up. I'm going to try powering it up in the usual controlled manner. Don't recall why this is missing. I know he gave me a box of spare tubes along with it. I'll dig up a 5U4 to put in it. It's got a fuse, so we got some protection there. What I want to do is the usual. I just want to eke a little bit of something out of it to make sure the power supply is okay, and that the filament supply is okay, the tubes light up, maybe we'll get some high voltage. But that's the other thing. So the high voltage on these is just a little clip that clips onto this metal. But for the test CRT and normal CRTs, there's a rubber cup with a sort of spring ring thing in it, a snap connector that snaps into an anode connector here. We don't have that. So I'll have to get creative with rigging up the high voltage. Alright, so let me get busy and I'll mount this picture too. This has a gap in it, so you can actually remove this. There we go. It's really not that heavy. That's the whole point of making them out of metal. Hey. It's a rebuild or not, but there's a ridge here. Alright, so this goes away. Really like the way they did the high voltage on this. I haven't seen that before. It's a little snap on the high voltage lead, and there's a corresponding snap on that plastic shroud. It has a copper inner strip that goes up against the metal. Neat. It's usually just a flimsy clip. So it's a bit easier to work on now. Now we can see what the electrolytics are. 1, 2, 3. Oh, you probably want to see underneath the chassis, don't you? So do I. Let's take a look. Huh. It's been partially recapped. Maybe fully recapped, but a long time ago. Yeah, partially. So they kept all the old electrolytics, even like this little guy here. This one, and the ones on top are all original. But they replaced some of the paper caps. I think I'll reuse some of these too, because some of these are Sprague 715Ps. Those are the good stuff. But I think these little brown guys will go, and there's at least 3 old electrolytics axial-leaded down here that gotta go. Candome resistor, hope that's still good. Oh, there's a fuse down here too. So the fuse on top maybe is for the flyback, or maybe it's just a spare fuse holder. And then here's the main fuse for the set. Literally a standard tuner. A standard company made those. Exactly the same as they used in Admiral. Sorry. There we go. So, very, very familiar with those turret tuners. Probably should be a cover on the side here. It's gone for some reason. Wire nut. Not sure what that's about. Another Candome resistor. We gotta hope those are good, or otherwise we'll be drilling them out and replacing them. Some of these replacements look pretty. It's similar to that Admiral I did a while ago, the electrostatic Admiral. There's a weird melange of replacement caps in here. They're these weird little blue guys. You get the high quality Sprague. this blue guy. I think some of these are pretty ancient. These little blobby things are peaking coils that are encapsulated in some type of coating. Oh, Jesus, some dog bone resistors down here. I know they said that they were hurting for part shortages back then, but those might be old replacements. I can't imagine they'd be using 1930s dog bones in a set made in around 1950-51. That's a little too crazy. And another Candome. Man. 1, 2, at least 3 Candomes in this. Candomes are notorious for going bad, and they don't make them anymore, so it's a little annoying when they go bad. There's a few other a lot of power resistors in this set. So it looks like C292, 293 on the front. On the back, maybe. Alright, so what I propose is a slow power up. I dug up a 5U4 rectifier. Here's a little itty bitty baby picture tube. Actually, it's the same deflection angle, I'm pretty sure. But yeah, a little bit smaller. And high voltage lead is not long enough, but let's worry about that when we actually have the set up and have some high voltage. Plug the base in for now. And to keep it from flopping around too much, I like to do this with a little clamp. So there we go. Alrighty, so do the usual. Actually, I want to power up this in. So it doesn't have a whole lot of tubes. What do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 that I can see out here. And there'll be a damper, horizontal output tube, and a high voltage rectifier in there. But there's a lot of empty space on this guy. Alright, sheet of cord. Let me get a few things set up and then proceed. Had some bad luck recently trying this. Hopefully we'll do a little better this time. So I just have around 30 volts or so. While this is starting to warm up, I'm going to clean off some of these tubes too so I can see what's happening a little better. As usual, I'm monitoring current. So in this case, we got a fuse on the set, we got a fuse in the sun core, we got a circuit breaker in the sun core. I'm not too concerned about anything bad happening. Plus, it was partially recapped. I'm guessing 70s was when it was done. I couldn't find any date codes, but all the caps are the old type values. Like they're 600 volt, not 630 volt caps, and they're like 0.02, not 0.022. And they're types of caps that haven't been made in quite a while. No yellow axial caps in there, that's for sure. Don't think I have the speaker for this set. I believe this RCA jack here is sound out. I think it goes into the radio, and then the radio plugs into a speaker. That's probably why there's lower tube count. I think it uses the audio amp in the radio portion. If that's a field coil speaker, it'll be a little more complicated for me to rig up. But we'll figure something out. Alright, I'm up to about 110 volts. It's drawn a little under 1.5 amps, which is reasonable. We have absolutely no sign of high voltage. So, we got to take a look inside the high voltage box. Could be that high voltage rectifier. There might be a fuse in there that's blown. Could be bad tubes. Let's find out. Ooh, well, there's something different for you. You ever see a flyback like that? Yeah, they were used primarily by RCA for like 1 or 2 years. That, my friends, is an air core flyback. No iron frame whatsoever. It's just a phenolic form and there's nothing inside. A thicker winding there, a couple turns. That's the filament for the high voltage rectifier. This here is your primary autoformer high voltage output, and then there'll be a bunch of windings underneath this to drive the yoke. Let's hope it's good. There is a fuse buried down in there. We got a damper tube. That's warm. This is warm. Based on my recent issues with high voltage rectifiers, I'm going to go for that first. Let's just, actually, before we do that, let's do the good old fluorescent bulb test, because even if the high voltage rectifier is bad, if all this is doing something, we'll have a fluorescent tube. Contact. If you ever start working on vintage TVs, get used to turning the lights off and on, especially in the early stages, because you just can't see stuff glowing properly with bright lights on. That's not good. So one thing what we can do with this off is we want to check to make sure this horizontal output tube isn't red plating. That would happen if the horizontal oscillator wasn't running. This tube would just be driven on way too hard. Let's see where we have the line voltage. Well, we're a little low. I'm only around 100, 105, so let's try going up a little higher. Just over 1.5 amps. You know, sometimes these oscillators just don't kick in until you get it to a certain voltage level. Don't. Alright, so. Alright. I mean, the guy said the set wasn't working. That's why we're here. So. Okay. But since it's been recapped. Oh, interesting. Since it's been recapped, I'm kind of jumping the gun a little bit on a few things. But hey, check this out. So in addition to the air core, there is a little transformer hiding down in there behind the damper tube. That's going to be a dedicated filament transformer just for the damper tube. You can see the red wires coming out there. I can't tell if it's original or not, because that wiring looks new. Newish. That's not at all uncommon back then, because these things can get some pretty serious voltage spikes on them. So you know they developed types like a 6W4 that could be wired in parallel with all the other tubes. Sometimes they were a little paranoid and kept them on a separate transformer. I cannot read. So I'm also working a little blind here since I don't have the service info. What I want to do is go through the Capehart service info and find one that matches the chassis layout, the tube layout. Crap! I can't read a number off. Well, I'll get out my tricks and shine a bright light and stuff because I cannot find a number on this damper tube. It's a pretty recent type. This is like kind of towards the end of tubes when they made them like this. At least for the octal types. Because if the damper tube is no good, then that's going to kill this. If this is no good, that'll kill it too. Or it could be one of the 6SN7s for the oscillator. So I'll start checking all this stuff. Well, I went through my notes. I believe I restored 2 of these chassis over the years, and I do have a copy of factory service info, which has waveforms, detailed schematic, There's a lot of versions of this chassis. They're slightly different. I don't think this matches mine 100%, but close enough. And it has waveforms and voltages, so fired up the old scope, looking at the grid, the horizontal output tube, and yeah, we get a nice signal on the grid. Right about the right frequency. If I can get this to go into voltage mode, yeah, about 20 volts peak to peak. And my printout is so crummy, I can't read what that voltage is supposed to be, but 20 volts peak to peak on the grid of the horizontal output tube seems like it should be doing something, and the voltages are in the ballpark. Should have plus 295 here. We're a little lower than that, and minus 90 we're more like minus 115, but it's in the realm of what it should be. Curious thing too, so with those dog bone resistors, those are the two 220k, there's two 18k 1 watters and two 220 ohm 1 watters. Well, that's what those are. These guys, those are the two 220 ohms. Those might be original. I'm not sure. The soldering looks so crude though. So I'm not sure. I'm not sure where we're losing it. I tried swapping out the high voltage. I swapped out all the tubes in that entire high voltage box, and nothing. So I'm going to keep investigating. I sure hope it's not that flyback. If it is, I think I might have a spare somewhere. RCA also used one that was quite similar. I think RCA pioneered these, or that's where I usually see them. They used them around the same era as this, 50, 51, 52. Yeah, so I did check the resistance. So it's a real simple thing that I recommend everybody does when they're posed with no high voltage, is check resistance between the plate of the horizontal output tube and the plate of the high voltage rectifier. That will tell you that this section of the coil is good. And it is. And the resistance is right about what it should be, 470 ohms. And the other section should be 1 something. I haven't checked that out. So I'm going to, basically, I'm just getting started. I got a bunch of stuff to check. But so far, nothing jumps out at me. Oh, I don't even need to go that far. I found the problem. Staring me in the face all this time. What's the one thing I didn't check? This coil. It's open. Horizontal linearity coil. What does that do? Well, couples power from this side. The schematic is cut in half here. It couples, well, plate of the damper tube. Yeah, that's pretty critical there. So also notice the boost voltage was like minus 50 instead of being plus 350. So yeah, what the heck am I going to replace that with? Well, I'll try to find a replacement value. So we know it's variable 2 to 27 millihenries. And the way this adjusts is they got a wing nut here, and then you can move the slug up and down. The thing about coils is, you think, well, just go online and buy a new 4 to 27 millihenry coil. Yeah, but there are other parameters. The Q, how much current can it handle? Obviously, we need one that has a variable iron slug in it. Okay, what can we do right now? Well, I could short it out. I could replace it with a resistor, which I think is what I'll try doing. Or a coil. See if I've got any chokes lying around. Alright, I tacked a filter choke across it. No, it's not the appropriate component, but it will restore continuity in the circuit, and I'm not going to run it very long. So let's see what this will do for us. Got my high voltage probe handy. Lead is over there. There we go. Bam. 9,000 volts. That's more like it. That's more like it. So, I got a little torradial coil in there right now. I'll try to find something more appropriate, but yeah, that was the problem. So for some reason with that being down, we can get the scope on the drive and see if the drive voltage actually went up, or is that, now remember, this isn't the exact chassis that I'm working with, so you know, I can't take those waveforms as gospel. Shoot. Just going to make tracking down the correct replacement coil a little tricky. Okay. Let's give this a try. I'm just using an alligator clip for right now. We'll just steer clear of it. Alright, I think we got high voltage now. I can kind of feel it. But I don't know about all these controls on the front. So I'm manipulating them now. This thing has had a few controls replaced over the years. And there is another potential problem with this, which is electromagnetic focus coil can be screwing up the test CRT. Double check that we still have voltage. There. So there should be plenty enough. Yeah, filament's glowing. So I suspect it's this focus coil. Try to manipulate a little. There we go. Yep, that was it. That was it. Cool. We have a raster. Oh, I think we might have just gotten really lucky. I unmounted the coil and inspected it and found a break in one of the fine wires going to the lug, and it was the outer winding, so I was able to unwrap a little from the main body to give me some length, tin the end, reconnected it, just soldered it back in, wrapped some Captain tape around it for protection. Let's see if it works. Yep, there we go. Excellent. Aha. Alright, so now that we've got a raster, I'm going to methodically go through and replace any out-of-spec resistors, questionable caps. We'll pick up when I am further along. I'll wrap this up with showing you the radio chassis. Alright, here she is. I believe this is radio chassis C-282. It's nice. I like early AM/FM radios that are no nonsense. Got a whole bunch of tubes, got its own power supply, audio amp, it's all self-contained, nice big dial scale here. What I mean by that is, again, the later sets, when AM and FM was more fully evolved and they would combine circuits and miniaturize things. There's a nice big chassis, really laid out well. It should be easy enough to go through and get it running. So I believe the way this works is TV chassis plugs into this, and then this plugs into the speaker and phonograph. I'm not sure which is which, but one of these should be for speaker, one should be phonograph. There should be an RCA jack on here somewhere. Yeah, I think it's this guy here. There's actually two of them back there. And power. In other words, this can be run completely on its own. Or the TV chassis, I think, plugs into the radio chassis. And sound comes out through this. But that should have its own volume control on the radio. On the TV as well. So far, the only issue I've got with this is a dial cord broke. I hate restringing dial cords. I don't even have any dial cord string. I'll have to order some up and figure it out. Maybe I can find a dial string diagram. At least I do have what I believe is the correct service info. So, that's going to be it for now. We'll pick up when I am further along.